we're going to look at designing experiments and errors from collecting data. Because everything, when you do a statistical analysis or research of any type, everything's got to be clean. If anything is messed up, put your phone away. You don't need it at all. No, put it away from you. I don't want to see it anywhere. No, off the table, in your bag. You can live without a phone for half an hour, 40 minutes. It's been done before. Some students do survive. So when analyzing data, it's essential to use appropriate methods and techniques for what you're doing. For example, would you do a questionnaire survey for a census? Okay, let's see. What is a census? You ever hear that word? Well, if you ever in church, when they talked about in the biblical times, in the days of Jesus when he was born, everybody had to go to their own town for the census. Census is what is called when you do the entire population. The United States does it once every 10 years. Each household gets one form. The head of the household fills it out about everybody inside there. It's called a census. Anything else below that, the moment you take away one of the population, it now becomes a sample. So there's a difference between the word sample and population. That's the difference between the two. So would you do a questionnaire, a door-to-door questionnaire if you're doing a census? No, because you'd have to go to every door in the United States, every door wherever there's an American living, and ask them the questions. So again, the best way of doing it is by a questionnaire. Let them do it themselves. You don't go in there and ask them the questions, they fill it out themselves. Whenever you take data, randomness is important. Because again, if you think about specifically how you're going to collect data from this person or that person, if you do that, you've just now influenced your data. It's no longer valid. So when you do an analysis of any type of data, you have to make sure it's random. The basics of designing an experiment and collecting data. We talked about this last time, a placebo. Typically, a placebo is a sugar tablet. It's a fake treatment of one of your groups to test to see if anything really happens or not. Why do they do that? Why do they give you a sugar tablet as opposed to the real medicine? No ideas? How do you know if it's going to work? If you give everybody the same medicine, how do you know that they were cured because of the medicine and not because the illness ran its course or they had an immunity to it? So if you're testing a medicine or any treatment, in order to verify if it's a valid treatment that you're doing is increasing your outcomes, you have to have one of two types of study groups. You have to have a treatment group and you have to have a control group. So what's a control group? They're the group that has nothing changed. They're the ones who get the placebo. So nothing changes in their environment. Then you have the treatment group that does get the medicine. So now what you do is you look at to see which one of these two groups has a largest amount of positive results. Is it possible to get results in both groups? If we're looking at cancer treatments and the control group who's got the placebos and the treatment group who's got the medicine, is it possible that both groups have people that are cured? Why? How can the people who get sugar tablets, how can they get cured? What's that called? What was that? You said, what is it? What is a placebo effect?
Because of their belief that it's gonna work.
Yep.
Works for them.
Psychosomatic. It's the power of the mind. They thought they're getting the medicine, so they convinced themselves that they got better and their body got better. Which then you have that side of people who believe that let the mind treat itself instead of medication. So now the first example, the Salk experiment. You ever hear of Salk? In 1954, an experiment was designed by the effectiveness of the Salk vaccine to cure polio. Okay, here, side note, polio was once cured. It was eradicated off the face of the earth. And then it came back. Because some parents believe that, I don't know, my kids don't need this vaccine. They'll never get polio. And sure enough, now we have epidemics of polio around the world. So that's a side note. Preventing polio, which had killed or paralyzed thousands of children. By random selection, of 401,000 children were randomly assigned to two groups. 200,000 were given the treatment consisting of that medication, and 201,000 were given a placebo, the sugar tablets, the sugar medicine. Children were assigned the treatment or placebo group and process of random and a flipping of a coin. Think of that. Your life is determined by a flip of a coin. Among the children given the Salk vaccine, 33 later developed paralytic polio. Of the children who got the placebo, 115 got polio. So what does that tell you? Is it a good vaccine or is it not a good vaccine? Well, if you think about it, out of the 201,000, 115 got people who had the placebos, 115 got sick. People who got the vaccine, only 33. So that's a good sign. It's not highly successful, but it's better than the odds. So that's what you're looking at. You see who gets the ailment after this treatment was presented. So now out of this, the placebo group, what does that 115 really tell us out of the 201,000? What does that really tell us? What's that? They weren't cured. They're the ones who got they were paralyzed because of the polio. That number tells you the percentage of each child of getting polio. Because out of the 201,000, take 115 divided by 201,000 and times 100, that's the percent of each child getting polio without any vaccine. So then what you do is you take this next number, 33, and divide it by 200,000, multiply by 100, and it'll tell you what percent this medicine was going to cure. So let's look at that. So we had 115 divided by 201,229 times 100. 0.06% chance of getting polio. 0.06. So if you don't let your child get anything, then you have a 0.06 chance. In other words, 6 out of every 100 children will get it. Now, That's your percent. Point six. Well, we're looking at here as 200,000, because we went for 200,000. Not just 100. So that's this saying is out of every, in that sample group, you have 0.06 chance times 200,000, then you get that. Now, so get the other one. Here we have 33 divided by 200,000, 745. 1.64% chance of not getting polio. So would you give your kid a polio vaccine? Yes. I mean, it's just a no-brainer. It doesn't, there's no treatment that says if it's going to hurt them. It's just that, well, this is what's going to happen. You have a chance of not getting sick. Okay. Example one. Describes an experiment because subjects were given a treatment, but ethical, cost, time, and other considerations prohibit the use of this experiment. Ethics is one of the biggest drawbacks whenever you deal with statistical analysis. You have to make sure that everything that you're doing in your study is ethical. That none of the subjects are going to get harmed. No private information is getting out, so you have to protect them at all cost. The cost of the medicine, of the center, of everything, the traveling and your crew that you have working for you. The time, you're talking about years of study here. Going out. Remember, if anybody has a cell phone out, please put them up, because if I see a cell phone out, then I'm not going to lecture anymore. I'm just going to give you a quiz. Okay, so again, I'm getting tired. You guys aren't high school children. You're supposed to be in college. You're supposed to be quasi adults by this time. Again, if I see anybody with a cell phone out again, we're going to do away with taking the test at home, and I'm going to make everything, your homework and everything, due on specific dates. I'm going to make this class very strict, because obviously some students don't care about my rules. And yes, it's easy to tell when somebody's on a cell phone and looking down at their crotch. Either you have a physical, mental problem, or you're doing your cell phone. You pick one of the two. So I'm not gonna say anything like that again. I'm just gonna simply say, okay, study your notes. We're having a quiz on this next time, and all tests are in the testing center. One try only. Again, I need you guys to start taking this stuff seriously. If it's easy, test out of it. If not, if I see anybody looking at their cell phone again, that's it. It's the last warning I'm giving this whole room. What is an experiment? We use the word a lot, but do we know what it is? An experiment is simply a treatment is being applied to a specific group. In an experiment, we apply some treatment and then proceed to observe its effect of the individuals, subjects. The individuals in experiments are called the experimental units and are often called subjects. So any one of those, typically the word subjects are used. That's if you deal with people. But if you're dealing with animals or anything else, then you deal with experimental units. What do you think an observational study is? And give me an example of what would it be. Observational study. What do you think it is? Just by the word, observe. What is observation? You're looking at something. So what would be an observational study? Give me an example. Who would use something like that? Yes, actually, yeah, I was at the Naval Academy in a research conference one time, and they said, okay, one person in this room has just been diagnosed with some ailment that's contagious. What do you think people started doing? They're looking around at who's coughing, who's sick, who's got a runny nose, and they start moving away from everybody. So yes, that's exactly excellent example. Uh, Zoologists, biologists, they observe animals from a distance. Anybody ever watch Star Trek?
Long ago.
Star Trek, the next generation has a rule that they have to follow. It's called the Prime Directive, which means that the people on the Enterprise, the spaceship, when they go anywhere, they cannot influence or affect anybody or anything in that new environment. Because think about it, if you went back in time, dressed as you are now with your cell phone, your watch, and everything, and somebody saw you, do you think it would affect how they live? It'd freak them out, first off. Who is this person? So by doing that, by simply changing their norm of living, you've just now influenced and changed their everything. There are scientists who go to like the Amazon rainforest and observe civilizations that we thought were extinct that still live in the Amazon. Yeah, exactly. And so they observe these people, they put cameras up and disguise them and just observe them from a very far distance. Because if they go in there and talk to them or anything, you've just changed everything that they're going to do from that moment on. And they're no longer going to be the same. Uh, think of this example. You want to study cockroaches in the kitchen. But when you walk in the kitchen and turn on the light, what happens? They go everywhere. So you just got rid of your study. So, but whenever you do anything, make sure you're out of the way. You don't influence, you don't change, you don't do anything to change, to modify the people you're watching. A lurking variable is one that affects a variable included in the study. A lurking variable. That's something that you didn't even think about that may happen. For example, let's look at the Amazon one. You have your camera up there, and then all of a sudden, animal comes, climbs the tree, and knocks the camera down. It's just dangling there with a wire. That is now a lurking variable. You've now introduced a new variable in the environment that these people live in. So you have to do what? You have to try to go in there and get that thing out of there before anybody notices it. If they do, you've just ruined everything. Here's a good one. Ice creams and drowning. Observational study. Observe past data to incorrectly conclude that ice cream causes drownings, based on data showing that increases in ice cream sales are associated with increases in drownings. Think of that. You're looking at a cause and effect. So it's saying that just because you're selling more ice cream, more people are drowning. The mistake is to miss the lurking variable of temperature and fail to see that the temperature increases ice cream sales. The warmer it is, more people go to the beach. The more people go to the beach, the more hungry they'll get. And the hotter it gets, you want to get ice cream to cool you down, or a soft drink or something like that. When I was in Hawaii, shaved ice is the national food. I mean, it is amazing how good it tastes. So People, when they get the slightest warm or hot, they go straight to a shaved ice sales and then they buy a bunch of it. Is that going to cause more drowning? No, because remember, it's warm outside and everybody wants to go to the beach on a warm day. So you'll have more people. The more people you have, the more accidents are going to happen. So is it because of the ice cream, or is it because of the temperature, or is it because of the beach itself? So there you see a example of a lurking variable. The temperature is something you didn't think about. The experiment. Conduct an experiment with one group treated with ice cream, while another group no ice cream. We would see that the rate of drowning victims is about the same in both groups. Here, the experiment is clearly better than an observational study. Designing an experiment. What is a replication? You ever hear the word replication? What does it mean? So what you're doing when you basically, if you ever do a study and publish it, the first thing people do around the world is they repeat your study. They'll take everything you put in there, they'll put the same test, the same number of students or the people you're doing, and they'll repeat it and see if they get the same results. Because if they get a different result than you did, guess what? Your results are wrong. Because if it's a true observation and it's a true study, then it will be true no matter who does it or where you do it at. You should get the same answers. Good use of replication requires sample sizes that are large enough so that we can see effects of the treatment. Large enough. What do you think large enough means? This is the reason why it's not an exact science. Because large enough, to me, could be 100. To you, it could be 50. Somebody else could be 1,000. So it all depends on what you're studying, the environment you're studying it in. All these things contribute to what is large enough. So if we're going to do a study here at Mountain View to see how many students prefer online courses versus face-to-face courses, how many students do you think we should study? Every student? Yes, that'd be optimal. But how many of you at the end of the semester do not do the teacher surveys? And for whatever reason, you don't do it. A lot of students don't. To be honest with you, at Mountain View, the return rate of students doing evaluations is 29%. 29%. That's pretty low. And the only way you can get anything to change at an institution is by doing those kind of surveys. Because who typically responds to those surveys? Is it students who have a gripe with the teacher, or is it students who want to praise the teacher, or is it the student in the middle? Typically, always the surveys you'll get are always people who have a gripe. And because of that, that pretty much negates that study. Because then, in order to make that a valid study, you have to see, why are you upset? Why did you not like this? Is the teacher doing everything? Because the other students didn't mind it. So what's wrong with you? So again, that's why you need every student to do those. And we'll do that at the end of the semester. It'll be an assignment. And you say, I hate this class because he made us do this stupid survey. Okay, now if you're forced to do a survey, how are you going to answer them? You think so? No, you would hope that it's truthfully, but if I'm forced to do something, it's like 1, 1, 1, 1, 1, 1. Yeah, just put the same answer all the way down. Some students will make pictures if it's a bunch of bubble charts, they'll make a picture out of it. Like, so again, now with that negates that sample. So yes, it's a catch-22 in that they're annoying to do, but they're a necessity of life. Blinding. What is a blinding? It's used when subjects don't know whether he or she is receiving a treatment. What's a double blind? Very good. Because the person who's giving the test doesn't know which is the treatment, which is the control. Exactly. There you go. You remember that or you knew that? And you thought, okay, biology is notorious for double blinds. Yeah, so the more influence from that test you can eliminate, the better it is. And that's where the blinding comes in. And the Salk experiment was a double blind. Randomness. What is randomness? We're going to look at some discussions for randomness. Ooh. If I asked you to write down 12 digits and any number from 0 to 9, 12 of them, without thinking, could you do it? Remember, you can't put any thought behind it. Could you write down 12 numbers from 0 to 9? The answer is no. Because simply by the act of simply writing something down, your mind is going to look at what you've just done, and it's going to say, "Oh, I put too many 9s in there, so I don't put any more 9s. I'm missing a 3, so I'm going to put a 3 in there." Once you do that, it's ruined. Even as basic as picking numbers, we have to use charts that are created by computers. Because only thing that can give us a random list of numbers is a computer. Because it doesn't have a thought pattern. It just spits out whatever comes up in a series of numbers. A simple random sample of n objects is selected in such a way that every possible sample of the same size has the same chance of being chosen. What does that mean? A simple random sample of n subjects is selected in such a way that every possible sample of the same size, n, has the same chance of being chosen. What does that mean? What do you mean by n subjects? What does n represent? Yeah, that's any number. Once you define what n is, let's say 5. So what you're doing now, you're going to pick 5 students at each time. So what a simple random sample is, I'm going to pick 5 students randomly. I'm going to put their names in a hat and draw it. Put the names back in, draw it 5 more times. That's the simple random sample, because every event still has the same probability, same chance of getting chosen. That's a simple one. Throughout, we'll use various statistical procedures. We often use requirements that are called simple randoms as defined above. And again, the selecting from a hat, that's the most common one that's used. Other sampling methods, here they are. Here's simple random sample. A sample of n subjects is selected so that every sample is the same as another event being chosen. Or you could do a systematic sample by selecting every Kth car or Kth item. There's like every fifth person. I go to my roster, I want every third person. So 1, 2, 3, that person's chosen. 1, 2, 3, that person's chosen. The only choice I have is what sequence I follow. Do I do every third student, every fifth student, every ninth student? Convenience sample uses data that are very easy to get, hence convenience. Ever been at a store and somebody asks you a survey, a question? How many of you have ever been to Costco or Sam's? They have those free samples there. Those are more than free samples. Those samples are the bait to get you there. Once you're there, they ask you questions. They're doing the survey without you knowing about it. They want to know if they're selling you sausages, they want to know, do you eat sausages? If you do, what kind do you eat? How often do you eat? They want to know all this stuff, and then now they help them with their study, with their sales process. Stratified sample. Subdivide populations into strata. Strata are groups or levels with the same characteristics. Then randomly sample within those strata. So we can have men versus women. And then from there, we can say, I'm going to pick every third person. So how is that helping in the randomization? Because if I just had the roster of students, they're both male and female inside there. But if I separate them, I now will have specific from each group. I've shuffled them, so to speak. Cluster sample. This is what a lot of places do during elections. Partition the population into clusters and the groups, then randomly select clusters, then select all the members in that cluster. So in campaigning, they want to know who you're going to vote for. What they do is they have where you live, you have blocks. Or if you're in an apartment complex, you have buildings. So you say, I'm going to pick this building, this building, and this building. And then which floor? First, second, third? I'm going to survey everybody on the third floor of this building. That's stratified cluster sampling. Or I say, I'm going to pick everybody in this building, top and bottom. I'm going to survey them all. Is that random? Yes, because you don't know who's in there. All right, now we have systematic sampling. We select some starting point and then systematically select every nth person or item. Stratified clustering, we did those. Can wording be of any effect on your sampling?
Mhm.
Yes. If you're gonna have a survey that you want students or people to fill out, make it so it's easily understood by everyone. Don't use high-finagle fancy words that nobody knows what it means. Because if you do that, then everybody's going to read it and then come up with their own idea what it means and answer it accordingly. You've just ruined it. The Pew Research Center pollsters conduct experiments to better understand how wording in questions can affect the responses of survey subjects. In a Pew Research Center survey of 1,505 adults in the United States, half of the respondents were asked about finding jobs, while the other half were asked about good jobs. Jobs versus good jobs. Is there a difference? Yeah. A job could be anything from working at McDonald's, working at Tom Thumb as a stalker, or working as an executive assistant at a law firm. But what is a good job? Yeah, a good job is whatever we have to first understand. Everybody has to agree on the word good. How would you define good when it comes to looking for a job? Job security. Even before that, I know you guys are, what's the first thing you look at any jobs? How much you get paid? Salary. How much do I get paid? Do I get paid hourly? Do I get paid salary? How much do I get paid? And then second thing you look for is what? What's that? Benefits. Yes. How much time do I get off? You'd be surprised during job interviews, those are the first two questions people ask. How much do I get paid? And how much time do I get off? Would you hire that person? No, because the first thing you're looking at is getting out of there. They're looking for absences. So yeah, you have the wording you use when you do a survey is very, 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 very important. Multi-stage samplings. Professional pollsters and government researchers often collect data by using some combination of proceedings, of the preceding simple samplings. In a multi-stage sample, pollsters select a sample of different stages, and each stage might use a different method of sampling. Like I said, Mira said the apartment complex, we're going to choose this building, we're going to use the third floor, so now we're going to use only that strata. So the more you could break it down and make it more randomized, the better it is. U.S. government's unemployment statistics are based on surveys of households. It is impractical to personally survey each household in a simple random sample, because they would scatter all over the U.S., making it impossible to collect information. Instead, the U.S. Census Bureau and the Bureau of Labor Statistics collaborate to conduct a survey called the Current Population Survey. The recent survey incorporates the multi-stage sample design, roughly following these steps. The entire US is partitioned into 2,025 regions. So what does that mean? You have the United States. You have to cut them up into smaller subsections, regions. The 2,025 primary sampling units are then grouped into 824 different strata. They're mixing this up really well. In each of these strata, one of the primary sampling units is selected so that the probability of selection is proportional to the size of the population. What does that mean? One of the primary sampling units is selected so that the probability of selection is proportional to the size of the population in each sampling unit. What they're saying there is, let's say you guys were all students in the whole building. I went by and picked each one of you all by random. Now I'm going to ask all of you all the same questions, and I'm going to pick one student's answers to represent all the students. For Mountain View, we'll do another thing for El Centro, for Eastfield. So that's what they're saying, is we're taking a big sample, breaking it to smaller and even smaller from there. Among the 824 selected primary sampling units, census data are used to randomly select about 60,000 households. That's it. In here, I picked one person. I picked you all from this school. I now pick inside here, I pick one person, and that represents the nation. The responsible person in each of the households is interviewed about employment status, and there you have your information. What can you see going wrong here? First, is it expensive, do you think? Well, yeah, because you have to take the whole United States and then break it up and then get more information from there. Is it time consuming? Very much so. Is it labor intensive? In other words, it will require a lot of work from the individuals doing it. Yes. Because now you have to go and interview each of these 60,000 people and make sure, first off, they're 16 years old or older. Now, here's a possible problem for this thing. If you're receiving unemployment benefits right now, and you get a survey, ask you if you have a job or if you've been looking for a job, What would be in your best service to answer truthfully or to lie? To lie, to try to keep on getting that money. So again, that's the problem with these things. You don't believe me? Go to any school early in the morning before school officially starts. They have what are called free reduced lunches, which are for the kids that can't afford, which were for Title IX schools. But for those free reduced lunches, see how many people drive up in Cadillacs and Lexus and BMWs and Jaguars. And these people are all below poverty level. So as a taxpayer, what do you think should be done? Remember, these people are getting free money, free food, so they can buy expensive cars and jewelry and stuff like that. Is that fair? Or is it criminal? Yes, it is criminal. And that's where they're trying to get to a point where they could start catching these people. Because I don't want my money going to that. The Human Project. In 2014, the Human Project is a prospective study in which 10,000 New Yorkers will be followed for decades. Why would you do that? Why would you follow somebody for decades? Well, first off, if let's say you want to see the benefits of public education, you'll start at a high school. Pick 10,000 people from a high school or from a series of high school, public schools, and follow them for the next 10 years. Because from there, they should either go get a job, go to college, or go to the military, or a combination of the both, of the three. After that, what should they do? Get a job, or stay in the military, or stay in school, professional school now. After that, then the school's over. Even if you're a doctor, lawyers only 3 years of school after college. Doctors are 4 years of medical school and then 6 years of residency. Then you're done with schooling. Everybody else, you're done as soon as you graduate. You get a job. So that would be a good study. See how well are these students doing from public education, as opposed to students with a private education. Obviously, you see disparity. The students in a private school, obviously, they can afford for a private education, so they have money already or connections. So that's kind of stuff human subjects are looking at. Uh-oh. How many more pages do I have? So there's an observational study. So in an observational study, when are the observations made? Is it over a past period of time? Is it over a single point in time? Or is it in the future? So if you're going to do an observation, are you going to look at things that happen in the past, in the present, or in the future? Then once you do that, then you're going to start noticing what you're observing for. What are you looking for? You can't just observe people to observe them.